Can you read that function? Is that legible? That is correct. Okay, good. Thank you.
Oh, who said that? Oh, yeah, I've seen that. Yeah.
Make sure to keep it to yourself, by the way. Yeah, you know.
Yeah. Oh. Wait, what? Oh.
Oh, no, that's a cursor.
Okay.
Yeah. There you go. That's better.
Whoa, no, I didn't. Yeah.
You're just about done?
4/3. Oh, wait, oh.
15 more seconds.
Yeah, and then 5 dead. Like.
Okay. So, I know it's kind of out of left field, but I'm just interested in hearing what your memory of the definition of pi is Rhea. Did you get something for that? Yeah, definition of pi, do you know? Okay. Okay. 3.14 is pretty important for pi, isn't it? Okay, and there's no pattern, so it goes on forever, which makes it a irrational number. Good. Anything else about that? Okay. Cool. I like it so far. Nico, do you have something? I saw a hand. I see I'm pointing at you. Is this true? Is that right? Well, let's take a look. I think you know the formula for circumference, don't you? 2 pi r, and you know that 2r is the same thing as diameter, isn't it? See, if I solve this for pi, I get exactly what Nico was saying, right? It's just a ratio of circumference to diameter. Nice. And as you were saying, I don't know if it's a definition, but it's important to know that pi is equal to 3.14. So if you imagine any sort of diameter and try to wrap it around a circle, it'd go a little bit more than 3 times, a little bit more than 3.14 times. So do we agree that pi is a fairly intuitive idea, circumference to a diameter? Okay. Let's take a look at this random formula. You plugged into 1 and you got 2. Okay. Was it difficult to plug into 2 and do this by hand? I kind of feel like to hear the answer. 1, 2, 3. It's like you practiced that. What was that? 9/4? 9/4, which is equal to, I believe, 2.25. Was it pretty easy to plug into 3? I think you get 1 plus 1. So 64/27. Is that easy to convert to decimal by hand? I think you need long division for that, but it's like between 2 and 3, I think. How about 5? Was that easy to do by hand?
No.
What'd you get for Ria?
Wait, I was gonna say like what is your X?
Say that again.
Like if you're talking about that would be five, because I figured out.
You figured out what?
Yeah,
Oh, okay. So, oh, okay. I'm so you found a pattern. Okay. So what's a pattern? What did
like it would be like X one over X and then all of that.
oh oh okay. So you saw the 4/3 and then the probably the 5/4 or something like that. Okay, nice. So you found a quick way to do the calculations. So according to what you're saying, if you plug in a 5, that would be 6 to the 5th power. Okay. And of course, finding 6 to the 5th is a whole different story, isn't it? Or 5 to the 5th. Did anyone get a decimal approximation for that? 6/5 to the 5th power? Okay, well, let's keep going. Did anyone plug in a 10? Let's do it. I think according to what Ria was saying, it's gonna be 11/10 to the 10th power. I do want to start getting some decimal approximations here. Um, so let's get our calculators out. And I do want to show you how to plug these in quickly. Let's see if I can make this happen. There. Perfect. Okay, so let's go here and go ahead and plug in that function. Have we used a table function in this class yet? I don't think we had an occasion to, but this is a good one. When you're putting a table of values out, this is just helpful. So what I'm going to do is, you see there's a table, but before that, I'm going to set the table by table set. So right here, if you don't have your calculator, maybe you could just kind of follow along with me or with your partner. Table set, so I do second table set. And the way it is, it kind of automatically does stuff for you. Like if I leave it like this, it's first going to plug in a 0.92, and then the next number that's going to be plugged in is 2.92 and 4.92. Like if I go to the table right now, I think that's what it does. But that's not what I want. So I'm going to go back to table set, and I'm going to change independent to ask. So it doesn't automatically put in values. So let's take a look at the table now and notice it's empty. If I plug in a 1, as you got, it is 2. Plug in a 2, same thing. I think it's actually going to do this one. I just found out that 6 to the 5th, 7,776. If I plug in a 10, is it going to start giving me give me decimals? If you have your calculator, could you do this and just kind of see what's going to happen to that y value as you plug in bigger and bigger numbers?
Oh, got it. Thank you.
Like that.
So you're plugging in larger values for x and just seeing what happens to the y values.
Oh, wait. This is how you do it.
Plug in 100. Did anyone plug in 100? Right, it's better than scrolling down if it just gives you these, right? You just choose a number. So I plug in a number that's bigger. 900. That's crazy. Let's do it. Oh, look, it just did it for me. You do a bigger number? Maybe 10,000? So what's happening to these y values? Are they getting closer to 3?
Okay.
Is that right? Do you recognize that number? Yeah, if we keep going, let's put in a billion. 1, 2, 3, 1, 2, 3, 1, 2, 3. Yeah, I don't think it's gonna get to 3. Oh, and by the way, if you highlight this one, it'll give you a more exact value of what it is. But it's not exact because as you know, E is what kind of a number? It's an irrational number. So like Ria was explaining before, it doesn't end, it doesn't repeat. So, but it does approach this. So last night I asked you to do a bunch of problems. I think maybe E was involved in some of them, and logarithms and exponential growth and decay and all that. So today I'm going to review some of those ideas because I understand that there was some trouble that some people had on it. So I just kind of want to make sure that the wrinkles are ironed out. But this is part of it, just a reminder of what E is. So let's go back to this guy. And if you go to your packet, to do. Okay, so before anything, let's scroll all the way down to, or let's turn to page 11. So the number E, by definition, is the limit as n goes to infinity of the function 1 plus. Any idea what the function is? 1 over, well, in this case, n is going to infinity. So 1 over n all to the nth power. So this is the definition of E. And it's much less intuitive than pi. I think you'll agree. But it is an important number in mathematics. I think you'll probably see some of it in econ if you take that class. And my guess,
Absolutely.
just once or twice maybe every day. Yeah, yeah, pretty much. And you do not have to memorize this right now, but I do want you to tuck it away in the back of your mind. What I do want you to remember that it's approximately equal to 2.71. 71 is all we need for this class. I don't know about other classes, but your teachers will let you know exactly what you need to know about it. Whoa, what's this doing here? Who's that kid? Who's that kid? Okay. So going back up to, this. I'm not going to fill in everything because I know that you've seen this before, but I do want to make some things clear. Exponential functions. When we graph exponential functions, I want to see 3 points. And when I talk about exponential functions, it's always in this form, f of x equals 8bx. It can be transformed with vertical stretches, compressions, transformations, translations, etc. I hope it makes sense. If you plug in a 0 into this exponential function, you get 1, no matter what that base is. And when you plug in a 1, you get a, yes. When you plug in -1, I hope it makes sense that a to -1 is 1 over a, resulting in those 3 points. Now notice is what happens if a is greater than 1. But if a is between 0 and 1, excuse me, that means we're going to have a number between 0 and 1, just like that y value there. But do you see the coordinates are the same? So those are the 3 values I want you to plug in anytime you see when you're graphing an exponential function. When I say plug in, I don't mean plug them in like a table. I mean, those are 3 that you're using. So going back a little bit for this, f of x equals 2 to the x. I want to see, we have point here at 0, 1. I went all the way back to page 9, excuse me. Also 1, comma 2, and -1, comma 1/2. Do you see that that's enough to establish the curve? As you may have noticed, every exponential function has that horizontal line called the an asymptote, specifically the horizontal asymptote here. Um, so if I'm going to graph this one, so I have my 0, 1, 1 comma a leaves us at 1 comma 1 half. 1 half to negative first power is 2. These values should look vaguely familiar. Same horizontal asymptote. Easy. Let's talk about this. There's 1, 2, 3 things happening here. Please discuss with your partner what's going on with these 3 things in our mental function.
It's spelled flat. And then kind of get good fit for the Y. And plus one, right? I think. And then yeah. And you like
Okay, so you've had a little time to discuss. Could you please show me in gestures what's the effect of that number 1, that first one, 1, 2. When I say number 1, I mean this. Oh, right, yeah. So both one. That it gets a reflection over the y-axis. Correct? Okay. Let's go to the third one. This is what I'm gonna do. The W we graph down 1. And for number 2, what is this sentence? It's gonna be a stretch or compression. It's gonna be a shift. That is to the right, to the left. Get it? How do you know it's to the left? It's plus 1. Be careful. Be careful. The horizontal translations have to be happening directly to the x, not to negative x. So to get a clearer picture of what's happening here, I'm actually going to rewrite this as 2 to the negative. Factoring that out, I have x minus 1. Minus 1. Does that make sense? So just be careful that horizontal translation has to be happening to x, not to negative x. So factor out that negative 1. So it's actually moving 1 to the right. So could you use the 3 points that you know I'm asking for and what these translations are making me sense? Check in on your neighbor when you're done or stuck.
Okay, so then,
I just like plugged it.
yeah. Oh, wait, okay.
Or here.
Oh, right. Okay.
Are we ready? Okay, let's start from the right. What should you do at this point, 1, 2? What happens first? Your reflection from third thumbs over here. And then from there, it's gonna go. Down one. Right. Are we okay with this? I'll do this in different colors so that points don't get confused with one another. So I think it went here. Picking that one. The original point is going to flip over the y-axis, which means the right where it is. And then from there we go. Just here. And you got the last coordinates? The third pair? The third ordered pair? What are the coordinates of the last one? The new coordinates? Yeah, for 300. -1 comma. -1 comma. -1. So like up here? No? I feel conflicted. Are we good with that? Any questions? How did you get that? I'm curious. Yeah. Oh, you plugged -1 into the original formula? Okay, now although this point may be accurate, I'm gonna just put an okay there. It's not quite the one I'm looking for. Notice, did I plug in anything for these 2 points? It's not wrong to plug in numbers, it's just I want you to avoid plugging as much as possible. That's the whole reason we have the transformation. So that point is okay, and it seems like it works. But I'm looking for something else. Will you just check in with your neighbor? What am I looking for? And I'm going to call on someone in just a minute. I'll be right back, though.
Oh, wait.
I'm not ready. Wait, no. Which one? No. 5 seconds. Okay. Thank you for participating. Lydia, did you find out where that other point goes?
No.
What were we talking about then?
Oh, we were just like trying to figure out like what we were missing.
Okay, well, let me help you through this. So this is the point we haven't done yet, right? What do you think we should do first?
Oh, wait, sorry, the point. Okay, oh,
Well, we did this one and this one.
yeah,
So now we're doing the third one, the one that we haven't done.
yeah, so then it would just be moved down 1 and then like over to or reflected, sorry, and then moved down to the right.
What comes first?
Reflection.
Reflection comes first. Okay, so here we're going to take this.
You'd like put it on the other side, so 1 comma, oh my God, 1/2.
You got it. Okay,
Yeah.
good.
And then you move it down 1, so that would be like negative,
You don't have to
Yeah.
do the coordinates, just kind
or
of.
yeah, you like move it down 1 and then over to
How far to the right?
right.
Or just like the directions there. Does that make sense? Nice, good. Under the gun pressure, performance. Yeah, we move it, we reflect it down 1, and let me just put a unit down there so we have something. And then back to red. Does that seem about what you were thinking? Okay. I hope it makes sense that these 3 would be enough to make the graph. And it looks like a B, something's gone wrong. And this is also really nice with one that we're getting is well not lining up, but it's arranging itself in appropriate fashion. Yes, hold on. So what are the graphics you want to snapshot? Thank you. Yeah, the horizontal asymptote is an essential part of the graph. So since everything's equal down one, let's definitely use that as kind of a backbone of the graph. Good point. Thank you. Something like that. Now we have the all the information we need to draw in our nice graph. Yes, Ria.
We would have to do, if you were like given this and you have to graph it, you have to choose those three points the way it's noted, not just plug it like as it once it's on one.
I do want you, well, I want a great graph. And the way to that is the 3 points that I gave you. When you're plugging in points, that often takes too long. I'm not going to say it's bad, but I don't recommend that way. And as long as you end up with a graph that looks like this, I'm quite happy. So go ahead and take a moment to let's see, work on the answers to these questions.
Yeah. Okay, let me try.
It's like, I think it's someone. I can search it. Then, what's search? All right. A domain and range. Henry, what'd you get? Okay. -1 what? To infinity. Are we including -1? Are we good with that? Are we including infinity? Okay, thank you. There's A, B. It's been a while since we've done this. Amir, do you remember how to do this? Okay, tell me what to write. Okay. Approaching. Are we good with this? Very nice. Limit notation. So like this, you wrote it underneath, or if you thought about it underneath. Okay. Of what? So I think we need a f of x here, don't we? Equals infinity. And then limit as x approaches equals -1. Thank you. It's been a while since we did these. Well done. Yeah, this is a nice intuitive way to think about it, those first two lines. So that's a good starter, but I definitely want you to be able to do these with limit notation. Thank you, Amir. C, Zach. Y equals -1. After what Amir just went through, that seems like too little. Can you also give us D, please? Yeah. Okay, so y equals 1, x equals 1. And normally on a test, of course, you'd write this in ordered pair. 0, 1. Cool. And maybe I should do this because this could be misconstrued as lines, don't you think? So 0, 1, 1, 0. Easy. Let's do one more exponential. Yeah, let's talk about this one. Let's make a parent graph first. y equals e to the x. Can you make a quick parent graph? Can you do? Okay, so the parent graph, I'm going to want the points that you're using to graph this. You need to discuss it before I call someone. Are you ready? Okay, Nico, can you help me out with this, please? Oh, we're doing the parent first. So, uh, exactly. We want those three values, and when you plug them in, you get what values? 1 comma. Okay. So 1 over e, you said? Okay, and 1 over e, were you able to approximate that? Do you know about what that is? A little bit less than 1/2. Nice, kind of in between 1.2 and 1.3, don't you think? So I would say a little bit closer to 1/3. Good. And then what was the other? Just about 2. Okay, so closer to 2 or closer to 3? I know it's closer to 2. Oh, closer to 3. Yeah, maybe I misheard. Closer to 3. Yeah. Maybe exactly at E, we could just put that there. And if it were on graph paper, you would be between 2 and 3, closer to 3. Cool. And this down here would be 1 over E if you're labeling your axes. And then you have this. So this is a parent graph. And just like we did the last time, take this, do a reflection, do a shift, done. But these are the 3 points that you would be using. Yes? Nico, thank you for your help there. I'll let you answer these on your own and graph the new graph if you like. Okay, these are all exponential equations. And I know you can figure out E just by your natural smarts, but eventually it gets kind of complicated and more difficult to do in your brain. So my recommendation, anytime you see an exponential equation, is to make the two sides so they have the same base. So we recognize that 81 could be rewritten as 3 to the 4. Once you have a power equaling a power with the same base, you can just take the exponents and by observation set them equal to one another. Yes. Did you already finish all of these? Okay, that's good. Some people did, some people didn't. So I'm going to give you a minute to continue working on these. If you did, you could be there for guidance for those around you. We finished these, then we're want to work on a separate problem from that section.
So when you know that, then you can solve for everything. And then you can solve for the last answer.
We're gonna go over B in about 15 seconds.
Yeah, because then you can solve for.
No,
No, it's not that. What you do? Yeah. Because you, then you, when you ask.
Okay. I do want to get this show on the road, so I'll do B, then you can do the others on your own. I'll help you out with that. So does it make sense for both of these to be written as base 8? No. That's a really bad idea. The new base will be 2 for both of them. And you know that 8 is 2 cubed. So I hope that this makes sense, that this would be a logical next step. 16 is 2 to the 4th. And then we just use our properties of exponents to say this is now 2 to the negative 3x plus 33 equals 2 to the 8x. And from here, it's just set up your equation, solve observation. This is 8x. It's not a heart. Oh, let's try this one. Did you already finish example 6? Some of you did, many of you didn't. We're working on this.
So it's kind of is one when you do when you plug it in something. Because we have the program, one, and two, one is three. So now, like, so, and you. Well, I think it's just that.
Maybe you're.
I like one tab, because I did too. I just want as like. Like, I think it's just that I think it's like
The original one, right, is like it's one comma like either one over A. It's gonna be like
I think
negative
so.
two, that means that we have to finish like in order to like.
Or just limit it to or shit, get it on the sheet with one.
I think, yeah, I think I just saw it, I don't know.
Oh.
Yeah.
I mean, yeah, good.
Well, and then like also.
I like, yeah, that makes sense.
Also, if
I don't know, like,
I think her positive, I'm there,
like this is great.
10 seconds.
Yeah, you sure? Cool. I don't know, like fast.
I don't have anything to back it up, but then like. I think it does, like,
I'm saying.
right, if it's one is.
Yeah, good.
Yeah.
I think it's just, you know, it's just stress.
Okay. So your attention, please. What's the strategy for this? How should I even start? Yeah, hold it. Do we agree? Okay, so how does that help with our equation? Perfect. Are we good? So I don't know what the base is, but it's exponential, so it's going to be f of x equals like a to the x, and it's going to be at least shifted down, but maybe left, right. I don't know, but down 3. So I'm going to do a little bit more examination. Did you graph this? I want to see what we see when we graph this. 1, 2, 3. So we have that, 0, -2. You have a point right there, and -2, 1. Okay. What do you see? I mean, it has to be negative x. Okay. Is that true? It has to be negative x? I like that. So you're thinking about it as a reflection over the y-axis? Oh, I like that a lot. Yes, Maria, do you have any other? And, okay, why do you say that? Oh, so if it's decreasing like this and that base is going to be between 0 and 1? Okay. It's a really good idea. I like both of them. Any other things that you see? Yes, Levi. Stretch horizontally. How do you know that? Because like thinking about the parent function, it's like there's a point of one common, something like 1 common a, and now it's like -2. Okay. Oh, okay. So we're used to the 0 in the middle and the -1, 1. And this open that up a little bit. Okay. Anything else that you see? One interesting thing about exponential functions is that there are multiple ways to see them. I'm gonna just kind of guide you through what I see, and hopefully it fits in with what you're thinking, what you're seeing. I see that here is a distance of 1, which indicates to me that there is no vertical stretch. Does that make sense? There's no vertical stretch. If there were, I may have to put some sort of factor in front. So I'm comfortable leaving it just a to the x minus 3. Now I'm just going to leave this as an a. I'm not going to make this a reflection, although I mean, you could if you put a negative x, I think that'd be a great idea. I'm just going to leave it as an a and see what happens. To solve for that a, all I'm going to do is plug in that second point there, that -2, 1. So let's see what happens. F of -2 equals a to negative first power minus 3. And I know that should equal 1. Did I do that correctly? Oh, a to negative second, excuse me. So a to negative second equals 4. How do I solve for a? Yeah, raise both of these to the -1/2 power. Does that make sense? That would be the quickest way to isolate the a. There are other things you can do. You can make it 1 over a squared and cross multiply if you wanted. I think this is a most direct route. So you have 4 to the -1/2. We're not comfortable with that number. So we rewrite this as 1 over 4 to the 1/2. 4 to the 1/2 we know is 2. So a is equal to 1/2. F of x equals, so this is a 1/2 to the x minus 3. Are we comfortable with that? Yes, Eileen. Ah, so you're saying 2 to the negative x? Is it okay to do this? Are they the same? They are the same. Yeah, so either one is perfectly acceptable. And I really like the way you looked at it differently. So it was increasing and just reflected as opposed to a decreasing function from the beginning. Either one is fine. Okay, I'll let you do that one on your own. Logarithmic functions. I'm going to give you about a 3-minute break before we get into this, just to zone out, stretch, whatever you need to do, and then we will continue with logarithmic function. We'll start again at 34. Yes, please. Yes. Introduce. Hi there. We were counting on them having 64% going over. So, I gave him a problem set, but I review for really.
Yes. I love your should go up too.
Just think it's a perfect teacher now.
Okay.
Like, yeah, if you didn't have like 45 minutes up and I was like, if that was like, if this stage is gonna take me.
Okay, yeah.
I just gotta skip it and like come back to it later.
Okay. Which for someone like that, I didn't really do a lot of giant points in distribution, so that's kind of fun.
Was there like a certain page that like you should have like stopped at or like, okay.
Yes, at 1 hour.
Okay, oh, but like,
You couldn't-
it's like, you just like keep going, like,
Oh,
well, I didn't, but like, I didn't, like, I was able to like get to page 19, like,
yeah, it was just these 2 seconds, but I figured out.
okay, okay, great.
In my folder, the backlog. Documents.
Well, I don't like the ones. What's the like a second.
Finish up your conversation. Okay, let's continue. Section 5.4. So if we start with this example, we're given a function, exponential function, and if you want to find the inverse of it, then you go about your business, right? X equals to the y, and now you know the next step is to solve for y. So you kind of run into a wall with the math that we've done this year so far. You may try to take the y-th root of both sides, but that would be solving for 2, and that's just weird. Take a y-th root of something. There's nothing we could do so far to solve for that y, which is why we have to introduce another operation called logarithms. So I'm just going to tell you specifically what logarithms are. If you have an exponential, b to the a equals c, we could rewrite this as log base b of c equals a. And this is bidirectional. So if you have a logarithm, you can write it in exponential form. If you have logarithm and exponential, you can write it in logarithmic form. I want you to notice some things. The bases are the same. And by the way, when you say this, log base b of c equals a. That's so you have to say the base. Log base b of c equals a. C is called the, do you know the vocabulary? Do you know what C is called in the logarithm? It's called the argument. And if you look at the exponential form, there are some restrictions on b that we didn't talk about today. Could b be any number? Has to be greater than 0. If that base is negative, crazy things happen. So b has to be greater than 0. And also, we have to remember that b can't be, well, if it's greater than 0, it can't be 0. But there is a number greater than 0 that b cannot be an exponential. Do you know? We're talking about real numbers here. Yeah. Oh, irrational. It could be irrational. One. Imagine what that exponential function would look like if you have 1 to the x. It doesn't grow much. It's just a constant function. So b isn't equal to 1. And that's for both exponential and for logarithms. So now that we have this, we could go here and say, oh, look, I have an exponential. I could solve this. It's going to be log base 2 of x equals y. So many of your exponential equations could be simplified just by putting in log form and vice versa. And notice I've solved for y suddenly. I also want to point out that in the definition, that since the inverse is, you're not going to see this 2 and the y together. So if you have that 2 as a base, you're not going to see y up here. Your log base 2 of x to the other side equals y. Just finishing this train of thought here, f inverse of x is equal to log base 2 of x. So that is the inverse of 2 to the x. Any questions? So for A, this is exponential. Will this be difficult to write in logarithmic? It's log base 3 of 9 equals 2. Also, I want to point out that the 3 should be small. It's like an exponent, but it's a subscript. The basic is subscript. And this 9 should be like, if you're typing, it's the same font and size and same line as log. So we're back to B as well. I'll be calling on someone for that one. Check with your neighbor. I'm calling someone. Hey, Kimmy, what'd you get? Yeah, for B. You said ln of equals B. Are we okay with this? Looks familiar? Thank you. Good memory. So can we remember that log base E is the same thing? So log base E is the same thing as ln, natural log. And I always write that in cursive, personally, because it starts looking like a 1. It's a little awkward. So that's what I do. Um, let's go here. Let's do the graph. I would like to make 2 separate graphs here. I know it says on the same axis, but I'm a rebel. F of x equals b to the x. Can you please plot the 3 points? You get the 3 points for b to the x. I'd like to call on someone for those 3 points. Eileen, what are the 3 points you have for b to the x? 0, 1. Okay. Put 1 right there. 1 what? Where'd the 2 come from? Because that was the case when it was 2 to the x. But with this one being b to the x instead of that 2, let's just leave it as b. But there's a but, isn't there? What's the but? We don't know B. It'd be nice if there was a little bit more information, don't you think? Did anyone else get that question? What is B? Is it possible that B is negative? For exponential functions, remember, B has to be greater than 0 and it can't be 1. So assume just B is greater than 1. What do you think? So if that's true, I'll just put a random B up here. I'm not saying that's 2, that's just a B. And if B is up there, then what's the other point that we have? Why is it 1/2?
Well.
You're stuck on that 2, huh? I feel like you're making up your own problem. 1 over B, exactly. 1 over B. And it's tough because it's so ambiguous and it could be 1.1, it could be 100, we don't know. But 1 over B is going to be something less than 1. We have that -1 and 1 right here. So it looks something like this. We have our 3 points. Thank you, Eileen. I know it's so abstract when that number, that concrete number is involved. And let's graph the inverse of this. The inverse of this would be, let's not label, let's just say y equals f inverse of x. Can you please graph this function? Considering what we have in the last one. Did you get it? Levi, what 3 points did he get here?
1 over b comma -1, 1 comma 0, and b comma 1.
Where do these come from?
Just looking around the coordinates of the normal function.
Are we good with that, everybody? Exactly. That's a definition between a function and its inverse. The x and y are reversed. So these are the 3 points that I'm going to want to see on the inverse of an exponential function, which is, of course, logarithmic. So this is y equals log base b of x. Those are the 3 points I want to see. A lot of people do the exponential first because they find that more intuitive and then just reverse those. But it's whatever you like. Now, this is, of course, if b is greater than 1. You can imagine if b were between 0 and 1, what it would look like.
B were over here, our point would be like up here. And then the reciprocal of something that's between 0 and 1 would be greater than 1, so that will decrease the function.
Any questions? One last question for you. What's the domain and range of this logarithmic function? Want to check with your neighbor before I call on you?
And then. Or well, actually. Oh, wait. So when you know your future. For, I think that's like right, like I'm sitting here, it's gonna be the domain range is here, it's gonna be. Basically.
Just inverse.
Oh, okay, well then, yeah, you're only gonna do it like this. Yeah.
Okay. I'd like to hear domain and range just of the inverse function from the one and only Sophia S. Let's hear from domain. Are we good? Any questions? Okay. So I'm going to give you some time, considering what we've just done, to continue working on 5.3 and 5.4. Discuss it. and look through all those problems to the best of your ability. And did you want your test back? Okay. Since you asked so nicely.
Mhm.
No.